Okay, AP Stat, we have our next example for fluorescent light bulbs. All right, so this company purchases a large shipment of the bulbs and they are going to accept shipments based on the following criteria. They are going to test 24 bulbs, they're checking them, they're selecting them randomly, and then they're going to accept the batch if there's only one or none of them that does not work. If a particular shipment of thousands of bulbs actually has a 4% of defects, what is the probability that it will be accepted anyway? So here's what we're going to look at. For part A, what does the random variable x represent? Well, in this particular situation, I'm going to let x represent the number of defective bulbs, because how many I have, that will determine whether or not I accept the shipment or not. So x is going to be the number of defective bulbs. Does x have a binomial distribution? Well, let's check our conditions. There is no reason to believe that the bulbs are not independent, so I'm going to write that the bulbs are independent of one another. And then I'm going to look and see if I have two categories. Well, the bulbs are defective or they're not. So I have either defective bulbs or not. And then I need to establish the probability of a bulb being defective. Well, if I know that there's a 4% rate of defects, then the P is going to be 0.04. So that represents, in this situation, the success, because that's what I wrote first in success or failure, right? Okay, just to remind you, I know that a bulb being defective sounds like failure in your head, but remember, this is for the purposes of establishing one thing or another. And then, of course, I have N is 24 because I'm going to randomly select 24. So it is, in fact, a binomial situation. So for my notation, I would use this right here. All right, so in part C, what is the probability that the whole shipment will be accepted? In other words, I want the probability that X, the number of defective bulbs, is less than or equal to 1. Why does that matter? Because I'm going to accept the whole batch if there's only one or none of them that are defective. So if the probability I accept it, or the probability I will accept it, that is going to be if there's one or less that are defective. So when I'm communicating about this, it means the probability that there are no defectives plus the probability that there's only one defective. So I'm going to use Staplet here to figure out what my answer is. So I'm going to change N to 24. I'm going to change P to 0.04. And then in my drop-down menu down here, I'm going to choose at most. Type in a 1, push go. I get 75.08%. Okay. All right, so I'm just writing it as a decimal. You can write it as a percentage, it doesn't matter. Now I'm going to look at the last question. What is the probability that the whole shipment will not be accepted? Oh, there's a typo. Poop. Okay, so what's the probability that the whole shipment will not be accepted? Well, you can do one of two things here. You can find the probability that X is greater than or equal to 2. And then you can find the probability that X equals 2 all the way up to the probability that X equals 24. This has already been more work than the other way will take. So if I want to know the probability the shipment will not be accepted, isn't that the opposite of it being accepted? So that would just be 1 minus 0.7508. Isn't that exciting, kids? I like it. I think it's magical. Okay, so let me get my handy dandy calculator out here to make sure that I don't mess up my decimals. Okay, that gives me 0.2492. Neato speedo. Pretty cool, huh? You're welcome. All right, so I'm going to go ahead and do the next example here. This is the medical test example. A certain medical test is known to detect 90% of the people who are afflicted with a certain disease. If 15 people with the disease are administered the test, what's the probability that the test will? And then you're answering all of these. So I've left space here for us to write our conditions. We need to decide if this is a binomial situation. So the first thing I'm going to do is write that these patients or these individuals with the disease are independent of one another. So those with the disease are independent. And you could write people with the disease are independent, something like that. Okay, the next thing I'm going to write about is my categories. Are there two categories? Well, yes, people are either going to test positive or not for the disease. Make sure you don't write that they have the disease or not, because I want you to notice that the 15 people involved in this all have the disease. And I am just trying to see if the test is going to accurately show whether or not they have the test. So my two categories here are that the disease is detected or not. And then, of course, P is going to be the probability the disease is detected. That's 0.9. And then N would be the 15 people involved here. So this is a binomial situation. All right, so I'm going to look at part A. I'm going to find the probability that someone is going to test positive for all 15, or sorry, not someone, but the probability all 15 will test positive. So I've got my parameters here, 15 people, 0.9. And so I want the probability that X is going to be positive for all 15 people. So I'm going to use Staplet. And N, it's going to be 15, probability 0.9. Going to find exactly 15. And it's 20.59%. Or 0.2059. Okay, all right, part B, the probability it's positive for at least 13 people. So I've got my parameters here, the probability that X is greater than or equal to 13. So it's going to be the probability that X equals 13 plus the probability all the way to X equals 15, which is not very much. You could have easily written X equals 14 in the middle there. And then, of course, I'm going to use Staplet. I'm not going to keep going back. Well, I guess I do for the inequality. Never mind. All right, so for the inequality here, since this is at least 13, I'll choose that. Push go. I get 81.59%. Or 0.8159. Okay, be positive for 8 people. My parameters are the same. The probability that X equals 8 is going to be 0.00028. Yes, you go to Staplet. Yes, you type it in. Okay. What's the probability? It will be positive for at most 12. Here's my parameters. At most 12 means nothing above 12, so less than or equal to 12. So the probability x equals 0 plus ... all the way up to the probability that x equals 12. Okay, so I'm going to go to Staplet. I am going to use my pull-down menu here, and I'm going to choose at most 12. Push go, 18.41%. Easy peasy, a lemon squeezy. You're welcome.